Hello everyone, this is our 7th session. In the last sessions you have learned network virtualization and what are the benefits of SDN environment will get by combining it with NFV, the challenges and the solutions of some of the issues of VSDN faced. The outline of today's sessions are: first, we are going to see the challenges and the factors which affects the SDN platform and the various applications of SDN platforms, and the last we are going to see the simulation tool to implement the SDN projects. Okay, now we are moving to our session. Software defined network is an approach to compute a network which allows the user to control the component of the networking environment through software rather than the traditional hardware based approach. In SDN, the logical layer is replaced by virtualized controller that can centrally configure all the network equipment. So SDN gives a greater efficiency and flexibility to industry so that they can adapt particular networking applications at any time. SDN is mainly changing how the networks are designed, built and operated. It provides the network operator and data centers to flexibly manage their networking equipment using software running on external servers. The Open Networking Foundation describes software-defined networking as dynamic, manageable, cost-effective and adaptable emerging network architecture which is needed for today's complexity of the application. The key highlights of SDN are: SDN is a trend of growing in data center design, management or utilization. Almost every technology vendor in the networking area has an SDN approach. SDN is a disruptor to traditional networking approach. A hybrid approach, that is SDN concept, is used with existing networking asset to give more benefits to organization. In early stage, user feels some difficulty to adapt SDN concepts. The hybrid approach that holds trials which gives the best way to approach the SDN opportunity. Many review of literature identified that the need of SDN is concerned with big challenges and effects. The main challenging factors of SDN is know-how, demand and implementation. The effects of SDN shows that the elements like decoupling hardware from software, the global view of the entire network are the unique features of SDN. The next, management. SDN provides easy deployment, programmability and maintenance of the network when compared to the traditional network. The last category describes the economic factors such as cost efficiency and the reduction of cost needed for the specific and skilled staff. Now we are going to see various applications of SDN where it has shown a high impact on efficiency and performance of the process. Cloud providers deploy SDN in their data centers for different purposes, and researchers considered energy efficiency, performance, virtualization and security are the objectives for their research. Energy efficiency is the most common objectives in SDN enabled cloud computing. As the cloud computer center usually consumes large amount of electricity globally, energy saving methods for data centers have to consider more. The energy consumption for the data center mainly relies on host servers, networking devices and cooling system and is proportional to utilization level of server. Performance can be improved by providing fine-grained control over the entire SDN network. SDN has centralized control to monitor the entire network. It can easily improve the network performance in case of traffic congestion may alter the flow path. Network performance includes not only the network throughput and latency but also the availability and the quality of service. To maximize the cloud provider benefits, host the number of virtual machines in cloud data center with limited resources. Virtualization. Cloud computing is implemented by using virtualization technologies which can make it possible to run virtual machine in clouds. Hypervisor running on physical host can virtualize the host resources. SDN is capable of virtualizing network resources such as switch and physical links which can be virtualized and leased to multiple tenants of the cloud data center. Security is an important objective in networks. There are two research directions in the usage of SDN in clouds. The first one is securing networks by utilizing the SDN and protecting core components of SDN from attacks. A new innovative approach of a software-based cloud infrastructure seems to provide a proper solutions for the new trends and domains such as cloud services, consumerization of ICT, data centers with different traffic patterns, big data and IoT. There are some specific application model are getting benefit from SDN. The applications are web application, map-reduced model, streaming model and batch processing model. In all this model, the traditional network was not supported much in all of its tasks. The web application model, user expectation is latency and spontaneous response, which is crucial in traditional networking. The map-reduced model requires large amount of network bandwidth and computing powers to process the workload. The streaming model generates data continuously, which leads a large data flow in networks. Streaming application includes audio streaming, video streaming and also Internet of Things appliances. In all the streaming applications need continuous network connection for transmission and acquire more attention. Researchers have studied both multimedia streaming applications and IoT stream data for SDN clouds. The next is batch processing. The jobs are processed in order and may transfer data between jobs. For this transmission, a constant and reliable connections are required. Providing constant bandwidth is crucial rather than the latency and response time. SDN-based network management for multi-clouds may provide different approach. There are many platforms that could be used by the researchers to emulate or simulate the SDN projects. These tools are used to perform experiments, study the behavior of the network and develop new methods to support different applications. Now we are going to learn some of the properties of currently available tools to support SDN platforms. The tools are Mininet, STNet, NS3 and Trima. STNet is a proprietary software tool and it uses the company servers to run the emulation or simulation projects. STNet combines both the advantages of emulation and simulation approaches. It also supports some of the controllers such as Knox, Open Day Light, Floodlight, POX, etc. STNet has a good simulation properties and in cloud services which is referred to as simulation as a service. Mininet is a network emulation tool that supports rapid development in SDN and it is mainly dedicated to open flow architecture. It is most popular because it is simple, available and flexible to SDN platform. Mininet uses Linux kernel along with the Python language scripts to construct a virtual network of large number of host networks. Mininet uses its built-in software tools to develop such networks through command line interface or to adapt the third-party software tools that implement other controller or graphical user interface engines. The last tool which we are going to see is Trima. Trima is an OpenFlow framework that includes everything the researcher needs to conduct an OpenFlow project. The source tree includes basic libraries and functional modules that work as an interface to the OpenFlow switches. It has integrated with testing and debugging environment that manage, monitor and diagnose the entire system with the network emulator and a diagnostic tool chain. The lack of graphical user interface and the use of programming languages such as C and Ruby may limit the popularity of this platform. Now we have come to the end of today's session. I hope you all have learned how SDN helps with new concepts such as Internet of Things, cloud integration and cloud services, big data and even improving IT consumerization and mobility. At last we have discussed some of the simulation or emulation tool that supports SDN environment. In the next session we are going to see SDN security concepts. Thank you.